A gourmet chef is renowned for her spherical shaped soufflé. Once it is put in the oven, its volume increases at a rate proportional to its radius. A shows that the radius are centimeters of the soufflé at time t minutes after it has been put in the oven satisfies the differential equation. dr over dt is k over r, where k is a constant. So it is given that it's a sphere, and also it is given that what volume increases at a rate. What is rate? Rate its derivative with respect to time. So volume increases at a rate, so dv over dt is proportional. Increases, it means this derivative is positive. It may be important in general, because if something is increases derivative with respect to time, positive, decreases negative. And is proportional, it means what? Directly proportional. And you remember that if something is directly proportional, general form is what? Some constant, and is proportional to its radius, so it becomes constant multiplied by the radius. And it is given the sphere, and the volume of a sphere, it's what? 4 over 3 pi radius cubed. And to get dr over dt, we need what? Dr. And how can it rise? We can differentiate this with respect to time. So dv over dt is what? 4 over 3 pi, and differentiate r with respect to time. It's chain rule, so it's 3r squared, and dr over dt arises because r should be considered as some function of t, and function cubed is 3 function squared multiplied by dr over dt. And we can see that we can equate it to cr, and to get dr over dt, to be what? Some constant. 3 cancels, but it doesn't matter. It becomes in general c divided by 4 pi, and it's another constant actually, and r divided by r squared, it's r in the denominator, and c over 4 pi, it's another constant. Let it be k over r. So we get dr over dt is k over r as required. B, given that the radius of the soufflé is 8 centimeters when it goes in the oven, what does it mean? When t is 0, r is 8, and 12 when it's cooked 30 minutes. So when t is 30, and notice that t is in minutes, r is in centimeters. R is 12. Yes, and question is find r when t is 15 and r is unknown. Notice that if k would be given, to find radius after 15 minutes, we can just integrate both sides using what? Definite integral, and actually separate variables dr, dr. Anyway, we need separate variables firstly, so it becomes r dr k dt. And if k would be given, so if there are no unknown parameters, to find what radius, we can use what? Radius changes from 0 to some unknown value r, let it be capital R, and time changes from 0 to 15, and you integrate and write limits, and this capital R arises, and you solve for this capital R, and it will be the answer. But now here we can not do that because there is unknown parameter, and we cannot calculate or find definite integral with unknown value, because it must be some value. So we should do what? We should consider indefinite integral and find what r as a function of time. Firstly, there will be some unknown constants, this k, and another constant c arises because it's indefinite integral, and that's why there are 2 points, two pieces of information, and then we just substitute t 1540 and find the value of the function. So we need separate variables and integrate both sides. R dr, it's what? It's just r squared over 2, is k dt, it's just kt, and plus some constant. It's not necessary to solve for r now because we need the values of constants. So, or actually, to be more easier, let's multiply both everything by 2 to get r squared is 2kt. Notice that actually we can denote it as another constant, and plus 2 multiplied by this constant, it will be some another constant. Let it be a, or you may write c again, it doesn't matter. Or actually, let's rewrite it also as another constant, so let it be a t plus p. Notice that we don't need k directly, it is not asked to find k, so to k it's another constant. So let's substitute t is 0, so when t is 0, r is 8, so 8 squared is 64, is just b, so b is 64. So it becomes r squared is 8t plus 64, and r is 12 when t is 30, 12. So 12 squared is 144 is equal to 8 times 30 plus 64. 64, so it's what? It's 80 is 8 times 30, so a is 8 over 3. So r squared is 8 over 3 t plus 64. Actually, r is square root, but it's not required to solve for r. In general, we need r at this moment of time. So let's substitute t to be 15. So at t is 15, r squared is 8 over 3 times 15 plus 64, and it's what? It's 104 centimeters squared. So r is square root of 104 centimeters, and we need to the nearest centimeter, and it's what, 10 and something. So square root, and it's 10.223 significant figures as usual, but here it's required to the nearest centimeter, so it's 10, so it's approximately 10 centimeters. And that's all for this question.